All right, guys, we're going to resume with some discussion of limits here. And we're going to talk about some examples, and then we're going to talk about some approaches, some tactical approaches you can take to resolving limits. So here, this is just a multiple choice question of sorts. So they're asking, based on the results of this table, what can you conclude is the limit as x goes to 3 of some function? We don't even know what the function is. And point fact is, we don't need to know what the function is. We're simply asking what's happening on the function in very close proximity to 3. Well, you can see stepping up from a hair under 3, a tenth of a unit, a hundredth of a unit, a thousandth of a unit below 3. This thing, the function, is driving towards 5. Okay. Likewise, from approaching 3 from values on the right side, slightly higher, a tenth of a unit higher than 3, a hundredth of a unit higher than 3, and indeed a thousandth of a unit higher than 3. This function is driving towards, okay, the value of 5. So the limit as x approaches 3 for this function would have to be 5. Okay. All right. For which function is the following true? The limit as x approach infinity equaling infinity. Well, again, this is asking the end behavior of the function. Okay. And the end behavior of polynomial functions, either one end rises, one end falls when it's an odd power. Looks like A and B are the same problem, but regardless, okay, the limit as x approaches infinity for this 5th degree polynomial rising on the right, okay? So is the 4th degree polynomial rising on the right, okay? This is a rational function. The highest power up top is x cubed. If we did the long division, this would reveal something to us where the first term would be 3x squared. So it would mimic in the long run 3x squared. So the right hand side would rise, and therefore the limit would approaching infinity would be infinity. So if you ask me, all of these, this is true for all of these, okay? Here is the easiest way of evaluating limits, the substitution method. And it's really the first order of business you should look at when finding the limit. Does it say it's going to work every time? No, probably not. But it's always the easiest to find, just plug it in. So all it's saying is to evaluate the function at the limit, at the value of the limit, okay? So if you're asked for the limit as x approaches c, try f of c. If it gives you a number, bingo, that's the limit. Nothing further to do, okay? It just says plug it in, evaluate it at this value. If you get a number, that's your limit. So that's the first order business, as you can see here, okay? Evaluate the limit as x approaches -2 for this x cubed minus 4 over 5x plus 3. I don't surmise that there's going to be any hold-up value causing a denominator to zero out, so I'm going to plug it in. I plug it in, I get a number, that's it. That's the limit, okay? That's the limit. What about this, the cube root of x? Well, the cube root of x is a function that has an infinite domain. There's no values for which the function is undefined. So plug it in, and that's the value of the limit, okay? The squared function, 5x squared minus 2x plus 1. Again, it's easiest. The function is what we call a well-behaved function, okay? The limit can be evaluated simply by substitution of the 3 in, and bingo, out comes the value of the limit. It's not always the case, but it's the first order business, something you want to try from the first time around, okay? Piecewise function. Almost always the piecewise function is going to ask you to evaluate the limit, at the break point. So this says, okay, for x less than 1, I'm 3x minus 1. For x greater than 1, I'm on this parabola x squared plus 1. So 9 out of 10 times, A piecewise function is going to ask you to evaluate the limit where the function breaks. It breaks right here on these conditions at 1, left and right of 1. And that's what we're asked to evaluate. The limit as x approaches 1 from the plus side. Well, remember, from the plus side would mean for values greater than 1. Okay? Okay, so we'll evaluate that from the plus side by evaluating it on the top piece. That piece for which it's defined x greater than 1. So evaluating on the 1 side just looks like you can plug it right in and it gives you 2. Okay? They want to know what the value of the one-sided limit is from the left side of 1. So that's for values slightly less than 1, which would be using the bottom piece of this piecewise definition. And so we plug that in. We arrive at the same value of 2. So since arriving at the value on the left and the right are in agreement, the limit as the function approaches that value is in fact 2. Okay, and it tells us that the piecewise function is connected right there. Here's another piecewise function. Okay, this piecewise function is broken up at the value of 2. So no surprise, what we're going to ask you to do is find the limit as x approaches 2. Okay, now maybe you have the graph, maybe you don't. Point in fact is you don't need the graph. You don't need the graph in order to evaluate the limit. It makes it easier, yeah, because it's a visual, okay? But these are simple functions, okay? You can use substitution to evaluate, and it should not be problematic, okay? So the question is, what is the limit as x approaches 2, okay? Visually, we see they're disjointed. Going from the left and the right, they don't come together at the same value like we saw with the previous one, okay? So visually, we're going to say, yes, looks like the limit doesn't exist. Let's pretend we don't have the picture. We're just going to look at the function. If we want to look at the limit as x approaches 2, we have to first look at it at the left side. The left side is for values less than 2. That means plug in, okay, evaluate, substitute the value of 2 into the top portion. That's the left-hand limit, and that is easy enough to do, which of course gives us 6. Okay? Now, let's take a look at the right-hand limit. The right-hand limit would be evaluating for values slightly greater than 2, which would imply the bottom portion of this piecewise function, okay? Again, which should be an easy substitution, okay? Evaluating at 2, we plug it in, the value of 2, we get 8. So since the left and the right side are not in agreement, okay, either from the from our evaluation of the function, nor from the picture, the limit as x approaches 2 does not exist, okay? We'll come back to this indeterminate form in the next video.